Hello and welcome to the next episode of our Brainfood Talks. My name is Bartosz. I'm a software engineer at Square, and I'm really excited and happy to be your host for today. This is a premiere for me, as this is the first Brainfood Talk live streamed on YouTube for me. It's also a premiere for us at Square because this is the first time we're not streaming from our head office in Vienna, but from Munich, actually, our new company branch in Germany. What is Brainfood Talk about? For anybody who is the first time here, at Square, acquiring knowledge and also sharing knowledge is a fundamental part of our culture. And this format tries to bring this culture, the piece of this culture, to a broader audience. Anybody who is watching this live has a chance on somewhere here on the right-hand side to post questions. At the end of the talk, I will come back to them and try to answer as many as possible. If you're not watching it live, still feel free to drop us a comment, a question in the comments below, and we definitely come back to you. Yeah, I think for the introduction, it's enough. And let's now jump into the slides. So today I'd like to talk to you about container-based development environments and how they can improve our day-to-day developer lives. Fundamentally, this talk is about pain and frustration almost every developer experiences from time to time, some more regularly, some less. But this pain of trying to get something to run locally, set up your local configuration for a new project, for a new team, or just new task, a new repository. And I remember spending hours configuring my Mac locally only to find out that the feature I supposed to implement or the bug I wanted to fix took only minutes or even an hour compared to the time I really had to spend on configuring, or only to find out that I couldn't reproduce the strange behavior my colleague experiences on her machine. It's always a time-consuming and very frustrating experience. And today I'd like to show you an alternative. Join me in exploring the quite exciting world of container-based environments, development environments, also short dev containers. Let's dig into the challenges they solve, the benefits they offer, and learn how tools like Gitboard or GitHub's code spaces can actually improve your day-to-day workflows. At the end of the session, you understand the basic concepts of dev containers. I hope you will understand the benefits and see the benefits it may have for your daily work as developer, and also learn how these tools can make your work more efficient and also more collaborative. So I was referring to a pain, and just recently I experienced it again, and this is actually the trigger why I put all this talk together. I wanted to contribute. I want to contribute to an internal tool that a colleague of mine developed at Square. And it was a very simple web-based application. The context, the domain of this application is not really interesting here. But it was fairly new repository, simple stack, having a JavaScript, some Node in the backend and an Angular frontend. And I thought I could improve the user experience when using this tool by introducing some new UI components. There were it's not really that important what it was, but the change was just a simple UI change I want to do. And when I cloned the repository, I thought, well, this application is a very little one, and I don't need to bother my busy colleague to really get me on track and onboard me. How do I run it locally and where to do the changes? I thought I can do it on my own. Well, obviously it failed. It failed for hours, really. I had the wrong NPM version installed. I had no database, and the application needed a database. Once I started some Docker, some local database, I had to find out how to configure the ORM mapper to really use the new database. And at the end, when starting the application, nothing worked really. Figured out that even though I had the database connection, I still lack and write tables, all the connections, and also the a set of data basically that it's required to really run and to show actually something in the browser. So I spent literally a day or so putting everything together so that it worked, that I could run it locally, and then at the end, the change of the UI component I was actually wanting to do, it was like removing one line of HTML code and adding 3 more with an extra dependency of a new module. So it was really a small, tiny fraction of time that I at the end that I used for implementing that, in comparison to the overall time I spent on this repository. Of course, I could do it differently. I could ask my colleague to extend the documentation, because the documentation did not mention anything about starting it locally. I could bother him and try to find out together with him how he managed to run it, what kind of configuration he had locally, and how which data he used, and do it basically on my own. Or I could just leave it, because why spending time on some internal tools? And I think, and as I said, this triggered me to do this talk, because there are alternatives out there. There are alternatives how you can do it better. And before describing what dev containers are, I'd like to show you an example of how they can actually make your experience better. So I pre-recorded this demo, so there's no chance of failing it. And basically, I hope you can see it. Basically, I could, as always, git clone the repository, open it in Xcode in my favorite IDE. But this time I could receive this notification: hey, there's a dev container configuration. Would you like to open IDE in container? Hitting yes would restart code, VS Code quickly. And now in terminal, if I look on my Docker containers, I would have 2 containers running. One main container having all the VS Code and the app, and also a database container for having a real database and data in it. Also, VS Code would actually start not only the editor itself, but also the application and the background. As you say, without any errors, there would be a port available, which I could just open in the browser, and the application is there, up and running, everything working, no errors, no configuring, no finding out what data I need. And although it's still in a container, as you could see in a Docker container, I'm still using my local host, my normal IDE, and a browser to open and access it like previously. So how does this magic work? Well, as the name suggests, we now package everything that we need for developing the app or any app into a Docker container, because containers are very mature and stable technology. don't confuse the production container, which we use since years for deploying our applications, which basically have only a tiny, thin layer of your OS and runtime in it, and the compiled application, with the dev container, which obviously now needs not the compiled application, but the source code to actually work on it. And not only the basic host dependencies, but also further dependencies like compilers, debuggers, and other tools. And this is the fundamental principle of having these dev containers. You have basically something very similar to what you have in production already. It's just that it packages your development environment. In the background or inside the containers, you not only have to make it to work. Actually, you don't only have libraries and tools installed as a Docker image, but you also have to make it working. You need obviously the source code, which is basically mounted from your local machine, so that any change is reflected also locally and doesn't go away if the container dies. And you need a piece of code that basically is the remote kind of extension of your IDE, so that whatever you do on the left-hand side, on the local VS code, is actually translated into the context of the container. So if I start the process, if I run my application, if I debug it, if I try to list files, I always have the context of the container. And for this, the piece of code that is running that is called VS Code Server, and is basically also it's an open source piece of code that makes all this possible. Obviously, VS Code is not the only one that supports this. You can have theoretically also different, on the left-hand side, different IDEs locally installed and still connect to this code server for the remote execution. Also, JetBrains, an IntelliJ IDEA, has its own kind of piece of software that allows this remote kind of connection. To make everything working, you don't only need a container, which is basically based on simple Docker files or Docker Compose files. You also need a piece of configuration that puts everything together, that reference the Docker file describing all your libraries and dependencies that you want to have installed, but also further customization. So for the dev container standard, all you have to add is basically a dev container JSON file to your repository. It's referencing what Docker file you want to use as like a host kind of container. And then also you can add further toolings and customizations to this environment. For example, you could say that when I use VS Code as my IDE, I want to have special extensions installed inside the container, so that you don't have to have all the extensions for all your projects inside, locally installed. But you can say, for this project, I need Angular and whatever extensions. For the other project, I need maybe some Java and Python extensions. Also, you can add some commands to when the container is built or when the container is started every time. So like in the demonstration, you can always start your API server, for example, each time or every time you work on the machine. Containers dev is the page that describes the dev containers standard. It do show or reference what kind of properties you can set to your configuration file. There is a list of pre-configured, pre-built images you can use. So you don't have to define your image, your host image, basically from scratch. You can rely on already predefined templates. And as well, also you can have, there is a list of so-called features, which are basically packages, which you can install into any container, you want. So these are basically a list of tools that you can have inside your container. So that's the standard. So basically, dev containers, to have this container running, you basically have to have kind of configuration file, like a Docker file for the Docker container. It's just Docker for Docker file, basically Docker file for Docker file, because now we add some metadata and customization layer on top of our Docker file. And so you may be asking, okay, how do I start with? How do I get into this experience of having my IDE basically in a container, executed as a container? And for this, I'd like to show you live how easy it is, especially if you're working with VS Code. So what I do is I have a repository prepared, which is basically a simple Flask view kind of service that has nothing prepared for dev containers. You see, it's just a plain repository with some server code, some server app, and there's also a view-based client code inside. And the README, as always, describes basically how to start it. It doesn't even say which kind of versions you have to install it locally. You probably have to find it out. I mean, Python 3 and NPM, yes, but in which versions, we don't know. But this is a typical kind of setup. If you're lucky on your onboarding way, you basically have these commands ready. And how to turn this repository into a dev container repository is very simple. As I said, all you have to do is provide a Docker file image describing all the dependencies you need to install, and this dev containers JSON file to have like the overall configuration. With VS Code and the dev containers extension, you can do it very easy. All I have to do is say, okay, add dev container configuration file, which lets me select what kind of packages I want to have installed. I could reference an existing Docker file if I had any, but I don't. I don't want to do it from scratch. So I would select a Python dev container as a base image, kind of. I will use the latest version. I don't know what kind of version I need for the repository. So I start with the default latest 3.11 version. And now I get to select features, so packages and tools I want to have inside my containers. And as you can see, the list is quite large and extensive. I don't need much of these tools. The only thing I need is basically having some Node and NPM basically installed for the front-end part. And as you can see, there is a package that already has NVM, Node, Yarn, and so on inside. So I select this, hit OK. I keep the defaults. So every package, especially for the features, you can customize package, like which version you want to have and what kind of behavior you want to have. But let's stick to defaults. And that's basically it. Now what I have is a dev container, .dev container folder with this JSON file, having a name. Let's call it Python and Node. As you can see, it basically references an existing image from Microsoft, a Python 3.11 image, pre-built Python image. You could have, instead of this, you could replace it with a reference to a local Docker file if you have one. or you can reference a private registry image because you have some base images already existing. There is one feature installed, which is this node kind of feature. Again, it's basically an image from official image from Microsoft. You can have community driven images, you can have official Microsoft images, or you can reference your own private images here. Besides that, I can add some further customization. What I like to do when working with dev containers is having this post create command, which basically is being executed or will be executed when the whole container is built. So every time I work with a dev container, it's already built and I can attach to it and continue working. Or if there is none, I have to build it or I can rebuild it. So this build operation takes place only not so often, but every time something changes on the dependency basically level, I want to rebuild it and I want to make sure that all the dependency are installed. So I basically say, okay, I go to the server part and install the Python dependencies, and then I go to the client part and install also the npm dependencies. There's also some other command possible, which is called post start command. So this will be executed basically every time I really start the container. So if it's already built and present on my local machine and I just want to restart it because I want to continue working on this project, this command will be executed. And for this, I'd like to have this Flask kind of backend part already running. So I copy the command and say, okay, please go to the server part, and every time I start the container, also run the Flask backend already. I also told you that you can have different customizations. How does it look like? Well, I can basically, whenever I have a need inside a project for a special customization extension, like for example, I need view because it's a view-based application installed. You see, I don't have it locally. I can add it to dev containers by clicking this kind of setup icon, and there is an option add to dev container JSON, and maybe we add Python extensions to have it as well. So add to dev container JSON. Basically, it's just a shortcut for adding these lines into the file. So I could write it down on my own, but it's so much simpler to just select what I need, and it adds this the extension with VS Code. Same would work with, I wanted to use IDEA, for example, IntelliJ IDEA or the IntelliJ stack. I could add the extensions and also configurations. So not only extensions are supported, but also some settings and properties. You can do it with this customization section. That's mostly the part, probably the most times you need these configurations. And now that I'm done, all I say is reopen in container. So just checking if I have anything running locally in my Docker. So my Docker PS, as you can see, is empty. I say again, reopen in container. So now the container gets built, VS Code starts, the remote extension starts inside the container, initializes all the processes. You already see, because I had the images on my machine, it was quite quick. The post create command installing Python dependencies run, also npm run successfully, and the whole start command is started basically my Flask server. I see there is a port 5001 available. You can also see it here. And if I open it, I will see basically the Python Flask application, which has this books endpoint where I see some books. And if I want to run the front end part now, all I have to do is to go to the client and say npm run dev for the dev container, which now starts another port 5173. And if I preview this one, I will see basically my application running, right? And everything, oh, I forgot to show you. Exactly. So everything runs inside this one container now. And although I have started the application and the ports inside the container, the whole VS Code stack and how it communicates between the client with the server makes sure that the port is even forwarded to my local machine. So I can open actually this port on my local host in my local browser. I can do it also in the browser just to show you. And yeah, that's basically the application here. Yeah, so that's basically how easy it is. Now all I have to do is commit this Docker container or dev container JSON file into my repository, and next time somebody opens this repository in his own in his VS Code, he will get, again, as demonstrated, this notification: do you want me to open this IDE in container? And if he or she clicks on yes, then everything will be basically executed in the same way on their machines. Something I also like to show you is the following. Since so let's close this container. Yeah, if I want to close the whole container, I can basically say close remote connection, and everything now is being basically shut down. The container should be gone in a minute or two. It will automatically be basically stopped, but not removed. So next time I start, I can basically attach the container already is built, and it can be restarted very quickly. Now, since we are already defining our development environment in the container, the question is, why not run this container in the cloud? Why do I have to run it locally, right? And the thing with that is that the dev container standard is actually the building block and the back, what is basically the fundament of GitHub's code spaces. You might have heard about GitHub's code spaces, where you can basically run your application in the browser. And the thing is, at the end, it's just a container based on this dev container standard that runs in a cloud VM. And it's very easy to, once you have a dev container standard or dev container configuration in the in your repository, it's very easy to bring the whole setup into the cloud. How to do it? Well, in VS Code, again, it's very easy if you have the VS Code extensions. You can see I have the dev container, and then you can also switch to the so-called code spaces. I don't have any running. What I can do is basically create a code space, which is essentially creating a VM and running the container there. So I have this repository. I also prepared already I already have the dev container file, the JSON file on a dev container branch. So just select this. You can see you can even now select how big the machine will be, because obviously you're paying for it. So how many resources do you need? And let's take the bigger one. Doesn't really care for the demo. And yeah, and now basically GitHub is spinning up a new machine. You can see into the logs, basically spinning up a machine, a VM in the cloud, installing their components, and then installing the whole container configuration we have described in our dev container file into it. And my local VS Code basically connects to it the same way as it connected to my local container. So if I look in my Docker, local Docker PS, you will see there is no process running. Everything we see, all that logs is coming actually from GitHub's cloud. Takes a couple of seconds, obviously, to spin up a machine. I think it's now done. Yeah, we're running the post create command. So our backend app is already being initialized. You can see it here. There is something already running. I see the code like previously. This is not something I have locally. It's really coming from the VM in the cloud. I don't have a port. Should have. I think the application is already started. I can add it manually as well. It should be automatically forwarded. So let's have a look if we can connect to it. That looks good. And I open the books. Yeah. So as you can see, the process is already running. It somehow missed to initialize the port for me. So I did it manually, but it's just a port forward that I added. The whole process is actually running already. And you can see, even though I'm actually in the cloud, so still no container running locally, I still can access it through localhost/books. Now, if I start also the front-end part, so I go to client and pm run dev. This time I will give it a flag, the host flag, because normally it should work without, but I noticed while preparing this, at least this application, that sometimes the port forward doesn't work if you don't give it, if you don't initialize the process with the host parameter. So I make sure this one works. Okay, as you can see, it now recognizes a new port that is running, port 5173, which is the view run dev server. And I can open it and see the application running locally on my local host, although it actually runs in the container of CodeSpace. So this works as well. And now that we have this in the cloud, I could hopefully already see it in my GitHub. So I go to the repository we just initialized. There's this code button you probably already know, and then there's the code spaces tab where we see a new code space running, which I can connect to actually. So if I click on it, I can open it in Visual Code, which would again spin up a Visual Code locally and connect to the container. I could even use JetBrains Gateway because it does support accessing VS Code and dev containers, so dev containers basically. But I also can open a browser-based version of VS Code and connect to the same container. All that is very easy and possible. And to demonstrate this, I just open it in the browser. Setting up CodeSpace. Yeah, the CodeSpace should be present. Now the repository, the mounts are being initialized. Again, I see my code. I see a terminal window. I should also see the ports being exposed. Close this, no need for that. Yes, exactly. So you can now see that also both ports for the API and the front-end server are also present here, and I can open them in the browser as well. Takes some more time because this time we obviously not forwarding it into, I can even open it in a separate window. We're not exposing it via localhost, obviously, but now we have a dedicated URL to access the exposed port, which is a secure connection. So if I take this URL and try to open it somewhere else, like in the incognito window, it will force me to sign into GitHub, and if and basically if somebody else tries to open it with his credentials, it won't be by default prevented. You can expose the port publicly, so this is this public-private kind of visibility. By default, it's private, so only to your account or to your team, basically. Yeah, and this is basically me having two different VS Code connections to the same container. So whenever I do any change here, just to prove it, let's make a small change to this page. I call it my best books ever. Save it. You see, because of the dev server, view dev server, this has been the page has been updated here and also here. And I see exactly same changes, basically because I'm in the same container. Yeah, that's actually all I wanted to show you. Mainly how easy it is to spin up or transform your repository into a very, very reproducible and consistent kind of thing, because it runs now in a container. And how easy it is to bring this container to the cloud, like code spaces, to really have a remote kind of environment now. Because now I don't need a $5,000 MacBook Pro. All the heavy stuff is being done in the cloud, and all I need is some kind of stable, more or less stable network connection, because obviously every action I do here is being forwarded and transformed on the container in the cloud. But I don't need that much power locally to run everything, right? I think that's it for the demo. That's all I wanted to show you here. Already touched on it already. So having your development container or development environment inside a container brings the question, okay, why not putting into the cloud? And I think it's a valid question. And if you look at every other stage of development process, like running applications, designing applications with Figma, collaborating with other people via Miro or Notion, having ticketing system and a project kind of management system and with Atlassian Cloud, why do we still have to stick to a local host for developing the application? Why can't we also bring the development of applications into the cloud? And this is not something I want to answer. I just want to leave you with this question. I do think it is kind of future, but it's not yet ready here. I only few examples and few people really already developing in the cloud. But there are many options. So today we've been talking about the dev container standard, which is basically the fundament of GitHub's code spaces. There is also the so-called Gitpod platform, which is basically the same approach. They have a different configuration standard, but they're using also VS Code as a IDE of the choice, and they're also running a predefined, pre-built workspaces in the cloud. There's no local possibility for running it locally, but only in the cloud. But essentially, it's the same kind of experience, and there are only few very tiny differences between those two. And out there in the cloud, there are also further platforms that bring this whole idea even furthermore. So not only having IDE in the cloud, but having like the whole kind of workflows in the cloud is what platforms like Code Sandbox, CodeSphere, and also JetBrains with the Spaces product try to do. So not only giving you a IDE in the cloud, they host your Git repositories, the package repository registries. They have CI, CD integrated testing capabilities, deployment, ticketing system, collaboration tools for communication tools, everything and built into one platform, right? And this is also very, very interesting approach, which goes, as I said, even further than having your platform packaged to a container. But it isn't the focus on this talk. That's why I just leave you here and encourage you to have a look at these platforms. It might be something that help you or your team. But the fundamental concept of having basically an idea and the development environment as a code is all the same for every of these platforms, right? All right. I think I arrived at the end of my talk, and at the end of what I had to show you. Hopefully, I could make clear what kind of pains and challenges dev containers try to solve, and how easy it is to have your repository basically and your project be packaged to a container. And reducing the onboarding time was my main kind of entry point, but it's not the only benefit. Having a reproducible and consistent environment brings even more benefits to the table than only the reducing onboarding time. First of all, we have a very similar environment now to production environment, right? Because in production, all our applications are already running containers. The application runs on a Linux-based container inside Kubernetes most of the times. Why should you develop it and spend so much time developing it on a Mac or Windows machine with completely different sometimes completely different set of environment and dependencies, right? Why not bring it into container as well, having even the same kind of base host image as in production? Also, having this container, which is every time which you can rebuild into the same kind of output, makes the whole environment more portable, especially across different platforms. So if you have in your team people with Macs, with Windows, with Linux machines, it's much more easier to bring the same consistent experience for everyone. And basically it removes any possibility of having something working on my machine and not on your. Relying on the Docker file especially, and the Docker standard, which is a very mature technology, makes it very easy to reuse across different projects. You can have a Java base image that every project that is working with Java in your organization can reuse. Still, it makes it very easy to customize on Docker file level, but also on the dev containers configuration file level, right? We've seen these extensions you can install for different projects. You can have different packages and tools installed for different projects. So it's still very easy to customize. Having everything as code makes it very easy to put it under version control, which makes it very easy to really update and evolve, right? You don't have to write scripts and message all your people using the same working on the same project. Hey, please update your environment variable, or please run the script. Otherwise, you can't run your application locally. You can just create a PR. You can change, you do your changes on the file level. You put everything in GitHub PR and can have it reviewed. You can have CI pipelines building the images after PR is being merged. If you work with code spaces, you can basically once build the whole container and restart it, so that next time somebody opens the repository has already an updated version of this environment. It also, having an under version control makes it very easy to start up and bootstrap your application from 6 months ago, right? Because if you want to trace a bug and you need the code from like months ago, well, with the code, there's also the description of the development environment. You can bootstrap the whole development environment as it was 6 months ago, with all the dependencies and all the versions used back then, although your application may evolve and have a new set of dependencies currently. The container isolations make it prevents basically any kind of conflicts between similar versions or different versions of the same stacks between projects. So if some projects are working with Java 8 and the others with 11 and the others with 17, for you as a developer, it's very easy to have all these kind of projects run simultaneously as containers without need of setting up your local machine to actually understand and to really work with different versions of Java, right? And all these factors basically make the whole developer experience much more smooth and more joyful because it's so consistent. It's easier to onboard people. It's easier for many people to work with the same application, with the same project, without any conflicts and incompatibilities. And you can even share your workspaces. If I have some issue on my workspace, on my container, and I can't solve it, I can produce a link, give a link to my colleague, and ask him to join me finding what's wrong. And it doesn't have to, and he or she doesn't have to reproduce all that on their local machines. As always, nothing is for free in this world. There are, of course, limitations, and it's not only down to the limited selection of IDEs. Today, we've been focusing a lot on VS Code, and it works most stable with VS Code. JetBrains do kind of support this standard as well, but they're working on their own kind of stack with Fleet, the new next-gen IDE, and the Spaces platform. They're trying to basically do a similar thing with their own tools chain. There is obviously a potential learning curve, especially for people not working with Docker, not working much with Docker. So understanding containers, the tools, the life cycles is something you need to understand if you want to run it locally on the cloud. There's always a kind of performance penalty because of the virtualization. You have to mount the resources, you have to give resources to your container, and depending on the application, how resource intensive is and how many containers you want to spin up, it might be something that you experience in comparison with running the processes locally on a fast Mac, right? Also, there's no one standard. I've been talking about the dev containers JSON and the dev container standard, which is coming from Microsoft, open source by Microsoft and driven by Microsoft. But it's not the only one. There is this Gitbot company which basically provides you with very similar experience, has the same approach, but uses a different configuration standard, basically. Also, the containers, these kind of containers are designed to be ephemeral. So if you need long-term storage and persistent, you need to get some cloud services basically involved, because it's not so easy to preserve the state in containers, right? And also there are some security considerations. Although containers per se give you the benefits of isolation, which is something in terms of security, a good strategy. But now you have to deal with lots of Docker images, right? And if you rely on publicly exposed Docker images, if you rely on publicly exposed images from Microsoft or even community-driven images, you can never know what packages and what vulnerabilities are there. So you have to basically apply the same set of strategies and security considerations that you hopefully apply already into your production containers. But despite the limitations, I still think, and I'm convinced that container-based applications and not applications, development environments are the future, and having the benefits of really improved consistency, reproducibility, scalability, portability is something that really make the development work even more efficient and more collaborative. With that being said, I would like to thank you for sticking with me for as long as now 50 minutes now. I hope I could convince you to have a look at this dev containers. Try it out at I can only encourage you to try it out, to give it a try, to have to add a dev container JSON to the next project maybe, and see if that really is something that can help you and your team with more consistent development workflow. If you want to continue the conversation, you can find me under this link. You can drop me messages and questions. I'd be happy to answer anything you have. If you like the video, hit the like button. Make sure you subscribe to our channel so to have even access to even more interesting mostly dev-related streams from the past and the future. Speaking of which, next upcoming the next Brainfood Talk will take place on Friday, June the 9th, where my lovely colleague Jerzy will be talking about platform engineering and how building internal developer platforms can even improve the developer experience even after they're using dev containers, obviously. And also he will be talking about which patterns you can apply when building such platforms. If you're interested in cutting-edge insights and talks about latest software practices, I invite you to come to Vienna. On the 1st of June, we will host a second edition of the CodeCrafts conference with lots of interesting talks and workshops. Unfortunately, the Seoul conference tickets are already sold out, but I was informed that there are still some combi tickets and workshop tickets available. So you still have a chance to get a spot there as well. And that's really my last question. Everything I have prepared for today. And now I'd have some time to look into the questions from the live audience. So again, thanks very much. And let me check if I have anything in YouTube. Okay, I see something. So the question is this also well supported in the JetBrains IDE? Yeah, so I briefly touched on this. So JetBrains does support the dev containers and the VS Code server extension, basically. It also has its own kind of mechanism. It's called Gateway, JetBrains Gateway. So you can connect to a dev container in the cloud and run IDEA or whatever IDE you're using, JetBrains IDE you're using. They're also working in parallel on their next gen IDE called Fleet, which is which works even nicer with the in the headless mode. So needs less resources and is basically prepared to be running in the cloud. I hope that answers the questions. But definitely from my experience, VS Code has like the most native and most nice experience in terms of having container based development environment. So we're building a container with all dev dependencies and scripting to automate the most important parts. Assuming a Flask application also need a MongoCD, can you automate that as well? I mean, like, I know you can, but how would you approach that here? So yeah, this is basically something I showed in the first example. Maybe you can remember with the internal tool I was touching on. You can not only reference a A1 Docker file that you define, but you also can define a reference, a Docker Compose, having basically multiple containers inside, one of which be like the main container where the source codes will get mounted, and the ID, the Visual Code server extension, will be installed too. But all the other containers from this Docker Compose will also be started and linked together, so from that you have access to it network-wise from the main container. And this is something I showed briefly in the first demo, where basically I had a Docker Compose, I had an app container defining like my node dependencies and where the VS Code server get installed to it, but I also had in the Docker Compose just a plain PostgreSQL image referenced, which also gets started. And I even put test data. I even mounted test data backup file basically inside this container. So I always, whenever the PostgreSQL container started, it also had data inside it. So yeah, if let's say a Flask application needs a MongoDB, I would definitely go the dev Docker Compose file path and have like a separate service for MongoDB with own configuration that runs alongside your dev container basically. And it works perfectly fine. I even had a project where we were spinning up, I think 4 or 5 containers simultaneously, because we needed a broker, we needed a Azure cloud mock, basically a storage mock service, and having I think a database as well. So we had like this 3 and then the main Java container. So we had in total like 4 containers automatically started basically whenever you open the repository. Okay, and then the last one I see, especially with file system access on macOS, the performance penalty can actually be quite large, assuming you use frameworks, etc. that write to FS quite a lot, reads from it a lot. Yeah, definitely. Anything that is resource intensive, either on memory resource or CPU resource level, or also file system, network system, anything that if your application needs lots of resources, has a high throughput, you will always get an impact on performance when running everything in the containers. I can relate to that, and that's true. That's the limitation. Yeah, you can't really work around it. In the cloud, I mean, you can have like big machines having better I/O throughput and stuff like that, but it's won't always work probably as nice as on very powerful MacBook where you natively start the application. So I agree to that completely. Okay, I don't see any more questions. But that's okay. We already almost over the time. I'd like to again thank you for sticking with me, for your time. I hope it wasn't wasted. I hope you learned something, and I only encourage you to add next time you open a repository, add a dev container JSON file and give it a try. See how easy it might be. Thank you very much. And with that, I say have a nice day and already a nice weekend.